Guys, so we got Jim Fultz on the podcast. He is from Copeland, and he's going to talk to us about some things that a lot of you may know about, some of you may not know about. Now, the heat pump thing is a trend. There's a lot of people installing them. We know that. There's a lot of heat pumps that have been out there for a very long time, and there's a couple of balance points we got to talk about. There is thermal balance point, and there's economical balance point. So thermal balance point, and you plot these on a graph, and when Jim's talking, he's talking about plotting and stuff like that. So you got to kind of visualize it, or you can, after you listen, you can go look at what one of these things look like. So you can visualize it and then listen again. So thermal balance point is the point at which the heat pump capacity, because it's derating as it's getting colder outside, is not able to handle or match the load that is in the building or the home, whatever it may be. Economical balance point is the point at which it's not economical anymore to run the electric side. Like it's a heat pump, it's electric, right? Maybe you got to switch over to something else like natural gas. So that's economical balance point versus thermal balance point. We're going to get into all of this right now with Jim. This is a two-parter, guys. This is the HVAC Know-It-All podcast, and I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, Jim, it's been a while, and we're going to talk about balance point today, and it's something that it's a good discussion for me as well, because I've never really sat and like calculated balance point. I've played around with balance point on thermostats to see if thermal balance point, I'm speaking of, on like a thermostat, trying to potentially push the heat pump to as far as it could go to see what we could get out of it at certain temperatures. So I played around with it there. Now, I was at a training course that I was actually the instructor on, and it was more to do with best practices of heat pump install and things that we should do during that install to make the system run and perform well. But balance point came up, and it was part of the slides and stuff like that. So I've never really sat and calculated an economical balance point, but I fully understand thermal balance point, where we're going to switch over when we start to derate a heat pump when it cannot keep up with the capacity that we need. So I want you to jump in, maybe quickly just explain what thermal balance point is, and then quickly explain what economical balance point is, get the quick definitions, and then we'll move on to some ways we can get those done.
Well, yeah, thanks for having me, Gary. This is awesome to be able to talk about this and explain it. And just simply the fact that when somebody says balance point, you really need to stop and say, what do you mean? Because the fact that there is two different types, and without that clarity, what is the difference between the two? And so thermal balance point is the main one that we're really concerned with when we're installing a new heat pump system, when we're getting into the heat pump market. And thermal balance point has to do with simply the amount of heat that heat pump can put out. A heat pump always has to be sized for the cooling load. If you try to size a heat pump for the heating load, especially in a colder climate, and you get enough heat out of that heat pump in the cooling mode, you're going to be able to cool that occupied space down quickly without pulling the latent energy, that moisture out. And so you're going to have a cold, damp space that you're working with, and that's not what we want. So number one rule of thumb, always do your load calculation and get that load for the cooling capacity. We size it to that, and then it doesn't have enough to keep up once we get past that point where the outside temperature drops so much that it cannot maintain that temperature. And let's go through a little scenario with that. And I'm going to use some sizes here just to help make that more clear. So let's say our load of our space was somewhere around 15,000 BTUs. And our heat pump capacity, we got an 18,000 BTU heat pump. So when we are, and that this is design, and this is again going to your manual J or going to HRI directory.org, and you can find your heating capacity at both 47 degrees and 17 degrees outside. And so let's first look at what the load design of the load is. At 65 outside, we don't have any load on the house. And we get down to around 15 degrees outside, and our load is now 15,000 BTUs of heat that we need. So that we're talking a little small room. We're not talking about a whole space. We're just talking about a small space here. Well, that heat pump has a rated capacity, and the capacities that for our scenario would be at 17 degrees outside, we can do 10,700 BTUs with that. At 47 degrees, we have the full 18,000 or 17,800 BTUs out of that. So we can plot that. And what we do is on a graph, we plot from 65 degrees, no load, and we're going to go to 17 degrees because 17 is what our other number is that we're getting off AHRI. Say it's 15,000 BTUs. So that line is being plotted on this chart. And then we're going to have a cross line that's charted, which is simply a lower number. At 17 degrees, we're only getting 10,000. At 47 degrees, we're getting 18,000. So that line's going up. And where those intersect, all of a sudden you start getting colder in temperature, and the amount of heat that heat pump is able to put out drops. And where those intersect is what we call the balance point. It's where the actual heat pump does not have enough capacity to take care of the load of the house. And anything colder than that point is going to need a secondary source of heat. And so we're not able to keep that up. And I'm sorry, you said a quick definition here. And
I just wanted a quick definition of what thermal was versus economical, and then we could talk about those things, right? So to me, I'll throw out what my idea is, and then you just tell me if it's correct. So thermal balance point is the point at which, so those that are watching, you can see it on the graph, they're crossing like this. Thermal balance point is the point at which your heat pump is not really going to perform to meet the demand of the load, right? So you have to switch over to either your backup or you have to add some supplemental heat to that. Where economical balance point is the point at which your heat pump is not economical to use because it's drawing too much energy and you might have to switch over to something else. Is that sort of something, does that fall in line with your thought process?
That's exactly. Good way to put it, Gary.
Okay. All right. Now, the first ever dual fuel system that I put in, right? Because when I started my company, McCreadie HVAC, I didn't do any residential projects or anything like that. But the first one I did, I just want to give a little bit of a story because it can relate to some people's jobs and their thought process. So because I have this podcast, because I talk to people like yourself and other industry experts on the podcast, I had many conversations down the line on is sort of residential based on load calculations and heat pumps and doing things the correct way. So I'm like, okay, we got this home, decent size home, probably about 3,500 square feet, something like that. So we did a load calculation on this place, and it spit out what we needed. It was installed with it was I can't remember what the size of the heat pump was now because it's going back like 3 years, but that really doesn't matter because the story doesn't pertain to the size. But it was a dual fuel setup. So it had a furnace and it had a heat pump. When I installed it, I went to the thermostat and we wanted to experiment. So within the thermostat, the settings, you could have a cutoff point at which you wanted the heat pump to stop and the furnace to come on. And what we were using was the local weather data because it was tied to the internet, right? The thermostat. So we're using the local weather data. And I think I just watched the video the other day in this training course that I was performing. And I believe it was 9.4, 9.5, something like that was the thermal balance point that we set in the thermostat. So for those of you that don't understand what that means, we were trying to run the heat pump in heating mode to minus 9.4 degrees Celsius. I don't know what that converts to in Fahrenheit, but if you do the quick conversion, you'll understand what that is quickly. So it was -5 that day when I set it up. -5 that day when I set it up. And the heat pump had zero problems taking care of that load. So when I left, I don't know I don't even remember if that winter, because it was closer to the end of the winter, even got to that point. But I hadn't had been in touch with the customer the previous, like the next winter, to find out if it was holding at the 9.5 that we set it at. I really don't know. So, because I kind of lost contact with them at that point. But that's kind of the thermal balance point that we played with. And here's another quick story about thermal balance point, but it's not, it is and it's not. So there was a customer that I had who didn't want to go with supplemental heat within the centralized system. Okay. This was like a 4-ton heat pump because it's a big house. He actually needed about 4 tons of cooling load as well. So it was a 4-ton heat pump. He had supplemental heat in the floors because he had electric heating in the kitchen and in the bathrooms, and he had 2 gas fireplaces. So he thought he had enough supplemental heat if he needed it. So he wasn't living in the house. He calls me in February. It's about minus 16-ish Celsius outside again. And he says the house ain't keeping up. It's like 17 degrees Celsius in the house. We can't get higher than that. He's like, I should have went for the backup. That was his choice. That was his experiment, not mine. I didn't recommend him not doing that. So we had to go and install the backup kit for him for the next winter coming. So just a couple stories on that. And what do you think about a negative 9.5? Here, let's look it up quickly. Do you know what it is, Jim, off the top of your head? Because I don't. Let's go negative 9. Let's look this up. So we'll get it in Fahrenheit. Negative 9.5 C to F. Looks like it is 14.9 degrees Fahrenheit. What do you think of a thermal balance point of, let's call it 15 degrees Fahrenheit?
Yeah, that's a great question as far as what do we need for that thermal balance point? And it's really all over. It really depends on that cooling load of the house. So to say that thermal balance point is going to be somewhere around 15, which is Fahrenheit, or if we go lower than that, 0 degree Fahrenheit, that'd be minus 17, minus 18 degrees Celsius. That may be your number. Your number is really going to completely be defined and determined by what the cooling load is, and how much that air conditioner can put out, and then what the heating load is, how much additional you'll need, how cold that can handle outside. As far as the heat pump itself, it's going to be able to run down that cold. Most of our heat pumps now, we can get clear down to that minus 17, minus 18 degrees Celsius or 0 degree Fahrenheit and not have any issue with getting heat out of it. The question is it enough heat for the house? And most of the time when you get down into those numbers, you are looking for that secondary source of heat. When you get that low, that's where the economic balance point comes in. And as I was first explaining the thermal balance point or the capacity, the load of the house balance point, those numbers cross each other. One's going up, the other's going down in direction on a graph. For a economic balance point, one number is going to stay a straight flat line. That's your backup. Your backup is always a specific efficiency, no matter how cold it is outside. Your high efficient furnace is always that high efficient furnace. Your electric resistance is always the same efficiency, no matter what. So on a economic balance point, what we're looking for is at the point where it's going to take more energy for that heat pump to produce that BTU of heat than what it's going to take for that backup heat to produce that same BTU of heat. And to get into calculations, that's something that's really hard to do over a podcast. It's something that you need some handouts or slides or something to go in a lot more detail to actually come up to what is that economic balance point. The other part of the economic balance point is what's your cost of electric? What's your cost of your backup fuel? If you're doing something like propane, your cost of your backup fuel may change depending on what season that you fill your tank. And so that's a number that can continually move, it's a number to consider. But the reality is what we really, really are interested in is that thermal, or what I also like to call it, the capacity, the unit balance point, because that's what your stories was explaining is the whole reason why that's so crucial. If you do not have that knowledge and that number of what that thermal balance point is, and it gets colder outside than what the heat pump can handle, then you have a homeowner calling you up saying, hey, we need to do something about this, because it needs to be able to discern exactly when to switch over to that backup heat.
I know Copeland has products on the White Rogers side that help with determining this, correct? So you were mentioning the Sensi Touch 2 and some of your defrost controls and stuff like that, right?
Correct, yes. So the Sensi Touch 2 in its programming has the ability to set a capacity or thermal balance point, and being able to set that balance point is just simply, you need to be able to calculate that number and know what that number is, whether it's 15 or 20 or 30 or -9 or I don't know those numbers. I don't have a full conversion chart in front of me here.
You might have to experiment, right? You might have to, you can look at a chart of a system, like you can look at a spec sheet, but those are generalized a lot of the time. So you might actually have to experiment with your heat pump at your own home, or hopefully you maybe you have a customer that's a little advantageous and they'll let you experiment at their home and just play with it. Start with a really low number. Can it handle this on a cold day? Okay, maybe not. Maybe we'll have to bump this number up a little bit, and then finally kind of fine tune where that point is too, right?
We can. We should be able to do a calculation on that and have a starting point to know where we're going to start at. And usually if you run the calculation of your heating and cooling load, as well as your knowing what we're dealing with, the capacity of that heat pump, you should be able to hit a number pretty close. Is it going to be exact? To your point, you may need to tweak it a little bit, but there is calculations to be able to come up with that specific number. And so with that, the Sensi Touch 2 not only has the ability to set that balance point, but it also has the ability to be able to keep that auxiliary or backup heat from kicking in until you have a predetermined temperature that you set that at. In other words, if you don't want that electric or that dual fuel to kick on until it gets colder outside, 4 or 5 degrees Celsius, if we want, which would be around 40 degrees Fahrenheit. If we want to say, no, we don't want that electric or that resistance heat on above that, why would that kick on above that? Well, there's a couple reasons why it would kick on above it. One, the thermostat setting has been adjusted more than 3 degrees from what the set point is. So if the homeowner's using a setback point, or if you just simply walked up to the thermostat and bumped it up multiple degrees, over 3 degrees, when you have a heat pump with a backup heat, it's going to sense that and say, hey, it's going to take a while to do this. We got too much of a disparity here. Let's kick that resistance or that backup heat in and stage to that. And once we satisfy the temperature, then we'll go back and run the heat pump the next cycle. We can shut that ability off for that backup heat to come on and say, no, we want the heat pump to do it unless it's below 4 or 5 degrees Celsius outside. At that point, we want to be able to say, okay, let's go ahead and use that resistance, that backup heat, alongside of the Sensi Touch 2. One more thing about that, a feature that is really cool that's built into the Touch 2 for dual fuel, is when you get to that point where you're switching over from the heat pump to the dual fuel, whether it's hit the balance point or you've got 3 degrees warmer on the thermostat than what the temperature setting is, it actually has a built-in timer that will start the sequence of operation for that dual fuel. And it's roughly about a minute that it will let the heat pump continue to run until that gas furnace has went through its pre-purge, its igniter, warm-up time, and within 5 to 10 seconds of that gas lighting in that furnace, that heat pump outside condenser will shut off. So you don't have that drop of temperature with the heat pump shutting off while the dual fuel's processing and starting to come on.